And this evening I'm going to talk about using Apache Kafka and KSQL to build streaming data pipelines, which sounds really cool, and it is. So I work as a developer advocate at Confluent, which basically means I get to advocate for developers, such as yourselves, both going to developers and telling you about cool stuff, but also really importantly speaking to developers and hearing your input on how you're using Kafka and ideas for it. Before working at Confluent as a consultant, building analytical platforms on Oracle and Kafka and Hadoop and all sorts of stuff, and I've been doing the data type stuff for about 20 years now. I like blogging an awful lot. You can find various blogs that I write out there along with Twitter. If you do the Twitters, feel free to follow me at @armoff. These slides and all the others I've done, they're on Speaker Deck as well. I'll also put a note on the Meetup group afterwards with a link to the slides. So that's a little bit about me. Just one little bit of audience participation, just a little show of hands. Who's using Kafka today? And who's using KSQL today? No one. Ish. Okay, let's see if we can change that. Okay, so what we're going to do is we're going to look at some of the reasons why people use Kafka and some of the ways that things like KSQL can actually help you build out data pipelines. And then we're going to do some demos. So people use Kafka in different ways. People understand Kafka to be different things. Some people think of Kafka as a message bus. It's a way of getting data from here to there. Or they think of it as a message queue. We can just do pub/sub, and it just does that. Or we can use it for integrating between databases, and it kind of does that. It actually does a whole bunch of different things. So we actually call Kafka a streaming platform. And the reason for that is you can build out an awful lot of capabilities using Kafka itself. So a lot of people start off with Kafka doing this kind of thing. We've got a database or many databases, and we want to get data as it changes over there, and we want to get it over to maybe our data warehouse or our data lake or something like that. And Kafka is commonly used as that bus in between. And it's great because it gives you decoupling of the components. You can integrate many down into one. You can switch pieces out. It enables buffering. If your target goes offline, all your messages get backed up. It applies back pressure, so it's great for that. But that's kind of like the first little bit of what you can actually build with Kafka. Because you can use Kafka to do stream processing. So Apache Kafka has got the Kafka Streams API. It's a Java library that lets you do stream processing within your Java applications. So you can actually start to take data. You can take data that's coming from different tables or even different places, and you can start to join it as it flows through Kafka. You can join it, you can transform it, you can enrich it, you can filter it, and we're going to see some examples of that. So you can use Kafka Streams for that. You can also use KSQL for that. And we're going to see what the difference is. And because we're using processing within Kafka itself, we're decoupling our different components, you can start to evolve your architectures. So starting off, we've got everything coming from a database. We've got our transactional system, we've got our customers, we've got our order events, and we want to enrich them. As someone places an order, let's find out who it was that placed that order, and let's enrich it as it passes through, so that when we come to do our analytics or our further processing, we don't have to do that join down there. So we can do it as it passes through, just on data coming from a database. But the power of Kafka is that it lets you evolve this. So you can actually say, well, today my data's in this transactional system underpinned by a database. But tomorrow, we start to evolve the order processing out into microservices. Probably our customer data still sits in the database, at least for the time being. So that processing that we define, that stream processing that we defined using Kafka, still applies. It's still just streams of data just coming from somewhere else. And because we've got the data passing through Kafka, we can use it in many different places. So you can use the data that you've got that's feeding your analytical application, your data lake, or whatever it is, your real-time dashboard. But you can also use that same data that you've transformed and applied your business logic to drive other applications, event-driven applications As soon as someone places an order in your order system, something downstream can react to that using that enriched and filtered data that you've done in Kafka. So you apply this principle of transform once, use many. So you have your transformation logic, your transformation code in one place. And because we have the data in Kafka, and you can reconsume data from Kafka, and Kafka persists data, we can stream it down to a data lake, operational dashboard, an application, many different places. So let's see an example of building it. So all of the code for this is on GitHub. It's all Dockerized and super easy to get started with. So we're going to go through this, and we're going to take this idea of an event stream. So we've got some rating events up here. So we've got a website that users can log into, and they can leave ratings. So we all know websites like that. You buy something, you can rate it. This is a website that people log on to, and they leave ratings about the product. They say, this product's brilliant, this product sucks. And they give it a star rating, 1 to 5, and a little message. So we've got the events that are coming from the website. It's a stream of events that are streaming into Kafka. And those events have got a user ID. So we know the ID of the person, the user ID that was logged into the system, but we don't know any more than that in that event message. But down here, in our database, we do know about our users. So we have our user ID and a bunch of data about them. What's their name? What's their email address? What kind of customer are they? Are they a VIP? Are they new to our new customer? And we can actually use KSQL to actually join these together. So we end up with a stream of ratings as they come into the system with information about those customers in. And then we're going to see how we can filter them out and say if someone leaves a bad review and they're a really important customer, let's do something super urgent. Let's stream all of this enriched data down somewhere like Elasticsearch and do some real-time analytics on it. Let's also take that data and stream it down to BigQuery or S3 for our kind of cold storage and long-term batch analytics, for machine learning training, all that stuff. But it's the same data that we're enriching in the same place. So to get the data in, we've got the producer API. Okay, so the Kafka producer API, it's a Java library, there's Go, there's Python, there's C, whatever, streaming the data directly from our website application. Our push notifications, this is a bit that I've just built into the demo, so we can cross our fingers and see if it works later on, but that's just using the consumer API. So those top 2 bits, they're just bog standard Apache Kafka, producer, consumer. A bunch of different language libraries available. But now we're going to see how we can use something called Kafka Connect. So Kafka Connect is part of Apache Kafka, and it's a configuration file-driven way of doing streaming integration between other systems and streaming data into Kafka, and streaming data from Kafka out to other systems. So we can use Kafka Connect for integrating databases into Kafka. You can maintain a real-time view of your data from your database in a Kafka stream. And this gets really powerful, as we'll see. And then you can also take data from a Kafka topic and stream it out to a target. Maybe it's Elasticsearch, maybe it's a database, maybe it's S3, maybe it's wherever you want. And there's hundreds of different connectors that you can get. And you can get them from Confluent Hub. So you go to hub.confluent.io, you search for the technology you're interested in, download the connector, and off you go. So let's see if this works. So we've got our producer API. There's our data that's coming in. We've got the user ID there. It's our foreign key, in effect. We've got our data here. It's on a MySQL database. And I'm saying MySQL. It could be Postgres. It could be any relational database. The methods for integration are the same. Here I'm using something called Debezium, which is an open source project for integrating with MySQL, with Postgres, with Mongo, and they're adding capabilities for Oracle and SQL Server as well. But it uses the Kafka Connect framework, and it lets you integrate relational databases into Kafka. So here comes the first demo. Does this microphone sound as bad as it does here out there? It's okay. So, could you read that at the back? Give me a thumbs up if you can see it. Awesome. So, we've got MySQL. It's a MySQL command prompt. And we've got a table called customers. We can go and look what's in the table. If I could type. There's this long-running argument, do you do live demos or not? Because if you're doing a live demo, you can't be talking, and if you're doing a video, you can't be explaining. So, okay, so select star from customers. We've got a bunch of customers. We're a small business. We've only got 20 customers. But we've got a customers table. It's got information as customers in it. If I say select star from customers where ID equals 1, we get information about customer ID 1. They've got a name, they've got an email address, they've got a club status, and club status we can come back to. But it's a bog standard table, information about our customers. Over here, we've got something which makes sure my demo is not about to fall over in a heap, which shows that I've got 2 Kafka Connect workers and they're running. If that said failed, I'd be walking out the door because it would mean it wasn't going to work. But it's all good. So this is Kafka Connect. It's just a shell script to show that it is running. To set up Kafka Connect, it's just a configuration file. Point to MySQL, point to my Kafka cluster, happy days. So they're running, and because they're running, I can go to my Kafka consumer. Okay, so Avro console consumer, this is just a bog standard Kafka tool. And I can say, go and show me what's in this topic here, the customers topic. Show me from the beginning. I'm piping it through something called JQ, which if you don't know, it is an excellent utility for working with JSON data. It formats it, it's like SED, but for JSON. You can format it, you can filter it, and so on. And here, we've got our data from the database. So you can see here, we've got Rika Blaisdell. If I go back to MySQL, not that one, that one. There's user ID 1, Rika Blaisdell. Okay, in my Kafka topic, there's Rika Blaisdell with the first name, the last name, all of the schema intact. So there's all my different users. You also get a nice bunch of metadata that comes with it. And really useful, depending on what you're building, you get the before and after records. So I'll show you that. So all of these, before is null, because this is the initial seeding of the topic. But now, let me scroll down to the bottom of there. And in MySQL, let's create ourselves a new customer. Okay, customer ID 42 is Mr. Astley. Someone got the joke. And now if I scroll up here, there's user ID 42. If I'd actually split the screen, it would be like that. As soon as you do the insert, it's in there. It's because it's using log-based change data capture. It's super fast. And now if I do an update, okay, so let's update customers, set first name equal to foo, where ID equals 42. So Mr. Astley changes his name, so we update it. So common thing in relational databases to change your data. In my Kafka topic, interestingly, we've got an update operation. So Debezium gives you a whole bunch of rich metadata around the data that's coming through. And then up here, there's my before record. So depending on what I'm building, I can actually say what's just changed in the database. Okay, so we can say, that's what it looked like before, that's what it looks like after. There's a second version of this. Let me show it you. And this one flattens the data out. So this we're going to use for our purposes, which is basically what's the current status of that database row. I don't care what it was before. I don't care about was it an update or whatever. What's that current status? So that's what this gives us. Okay, so here it says ID 42 is Foo Astley. If I scroll up to the previous message says it was Rick Astley. But it's just a sequential stream of it changes to my database with the current version of that record. Make sense? Make sense? Thumbs up? Good. Anyone still awake? So, we've got data. Let me put the thing back on the screen. So we've got data coming in from our relational system into a Kafka topic. Anything that changes in our relational system is going to update straight away in our Kafka topic. And then we've got events coming in from our transactional system with the ratings that are just flowing into a Kafka topic as events do. But we've got a synchronized copy of our database in a Kafka topic. So when you start thinking about building stream processing applications, a common question people will have is, how do I do a lookup out to a database? I need to call another service to do a join out to this data. Usually, that's the wrong pattern. The right pattern is, I have data, I will stream it into Kafka. As something changes somewhere else, that state change streams into Kafka. And then you can do your joins in Kafka. So, let's do some joins. We're going to do this with KSQL. So KSQL, it's a declarative stream processing language, and it's the streaming SQL engine for Apache Kafka. So it lets you use SQL statements to define stream processing applications. What KSQL is not is a way of integrating your analytical reporting tools with data in Kafka. It can, but it's not designed for that. It's designed for building applications. You can use SQL to declare the transformations that you want to apply to your data, the joins, the filtering, the derivations, and then it runs as a continuous application. So you can use Kafka streams if you want to, if you're a Java coder, if you need the kind of the low-level access to the data, because KSQL is built on top of Kafka streams. So it's just another level of abstraction. But because it's SQL, it opens it up to everyone. Hands up if you don't know SQL. Go on. There's always one wise ass who's like, I don't know SQL. Everyone knows SQL. Hands up who doesn't know Java. Me? Yeah? Okay, there's quite a lot of Java people here. But not everyone knows Java. Everyone knows SQL. So to preempt a question that then comes on from that is, I'm a Kafka admin. I'm scared because all these SQL people are going to screw up my cluster because they're going to start running SQL against it and they don't know what they're doing. That's a separate question. You can set up access rights, you can have sandbox environments and so on and so on. If you have people who want to do stream processing, who want to build stream processing applications, they can. How you manage it, how and so on, that's doable. It's a separate topic. It's not like a free-for-all. It's the same with databases. You don't just give everyone in an organization access to a database. It's locked down, there's access rights and so on and so on. It's the same with KSQL. So with KSQL, you can use a command prompt, you can use Confluent Control Center, you can use the REST API if you want to prototype the SQL that you're building. And we're going to see this in a moment. So you build out your SQL statements. You can use SQL to explore the data in your Kafka topics, to prototype the kind of joins and filtering that you want to do. And then you take that SQL file, and that's your application code. You stick it in source control, you run it through your testing environments, you deploy it to production. And production is headless KSQL servers running in a cluster if you want to scale out the workload, because KSQL's built on Kafka streams, which is built on Kafka, which is a hugely distributed system. So in terms of big data, we're still talking big data. We're still talking elasticity, parallel processing, and all of that good stuff. So let's start off simple. Let's start off just by looking at the data we've got coming in from our website. Events are streaming through into our website, and we want to filter those out for a particular condition in the data. So we're going to say if someone leaves a rating that's lower than 3 stars out of 5, we're going to say that's a poor rating. That's not very good. And we're going to stream that to a separate topic. Let's see how that works. Okay, I'm at my KSQL prompt. It's just like a MySQL prompt or a PL SQL prompt, or it's a SQL prompt. I can say, show me the topics on the system. So we've got a bunch of different topics. If I scroll up, we can see we've got one called customers. That's the one I showed you before. We've got a bunch of internal topics. We've also got one called ratings. So I've got a ratings topic. I can say, let's print ratings. And now that's a real-time stream of the data that's coming through from the website. Okay? I've got a website running under here. Or I've got a dummy data generator. Either way, we've got data that's streaming into a Kafka topic. So I've not had to use any console tools here. I've not had to say it's in Avro format, it's in JSON format, it's whatever format. KSQL's simply gone to the topic, worked out what serialization has been used, and it's printing the contents of that topic in real time to the screen. So now we can create ourselves a stream in KSQL. So if I just run that and cancel it, we can see something up here. KSQL has inspected the topic, and it said, aha, it's in Avro. So Avro is a way of serializing your data. It's great because you keep the schema with your data. It's put in the schema registry. It's nice, it's binary, it's compacted, and all good stuff like that. And it means that when you come to use your data, the schema's there for you. Because what we're going to do now is we're going to say, create stream ratings with this Kafka topic, and it's in Avro. I've not told it anything about the schema. Because it's Avro, we have a schema already. And we can check that. We can say, describe ratings. OK, ratings has got a bunch of columns. How does it know it's got columns? Because it's Avro. It's got the schema. If this was JSON or just delimited data, I'd have to type in all of those columns and data types. And I'd probably get it wrong, and then it wouldn't work. So Avro is a very good thing to use. And we can do a select. So we can say select star from ratings. And now this is actually going against that Kafka topic and showing a live feed of that data. So far, this is just like using the console consumer. What's happening on the Kafka topic at the moment? Except we're using SQL to work with it. So you can say select star. Oops. But we can also say select a bunch of different columns. Now this is where the power of SQL and schemas comes in. You can actually say, I want to just see the stars, the channel, so is it from an iPhone or an Android or the web? What was the message from my rating stream, and with a predicate, where the stars was less than 3. And now I've got that coming back. There's my star ratings, the channel, and the messages. So this is really, really powerful. You've got a stream of data in Kafka. You can start to filter it out straight away. But so far, all we're doing is writing it to the console here, which is fine for exploring your data and understanding what you're working with. But even more powerful is if you can create another Kafka topic containing the results of that. Every message that comes in, every message that exists already, because Kafka persists data. Take all of that data and continue processing on into the future. Let's write that to a separate Kafka topic. So with that, in the database world, okay, so there's a ton of Java people here. Hands up, database people. Come on, who's a database person? Come on. Okay, there's a few of you. So in the database world, there's a statement called create table as select. And it's a useful way of saying I've got a table there. I want to create another table that's a copy of it, either a full copy or just with a predicate and some of the data. In the KSQL world, we have create stream as select. So we know what our select statement's going to be. It's that. Select the stars, select the columns from the source with a predicate. So now we can simply say create stream per reviews as, and there's my select statement. So I run that, and I don't get any output coming back. Where's my output? Well, it's created the stream, and it's running. I've written my first application. Let's go and have a look at it. Describe per reviews. Okay, there's my 3 columns from my select, plus a couple of system columns. Let's have another look at it. Describe extended. Here's my runtime stats. How many messages have I processed? Okay, let's run it again. I've processed 54, 56. It's an application with metrics. If I page up, it'll tell me it's writing it to a Kafka topic. Okay, the Kafka topic that it's writing to here is called per reviews. And under the covers, I'll do questions at the end if that's all right. Under the covers, there's a Kafka topic that's been populated continually. So we have our source ratings topic that's coming in, being populated up there. We've got a single SQL statement which says, filter it where it's less than 3, and it writes it to that other topic. But it's not just what was there before, it's what was there before, and every new event that comes in. Really, really powerful. So now, let's do the cool stuff. Let's do the joining. So now we're going to say, we've got our data from our database, we've got our events that are coming in. Wouldn't it be useful to know when people leave reviews, who are they? Because you may have situations like you've got a really important customer, and if they leave a bad review, you're going to care. If you've got someone they've spent €10 6 months ago, but if they're spending €1,000 every week and they leave a rating that's bad, you want to do something about that now. You don't want to be kind of doing your analysis on your data lake next week, and well, yeah, these guys weren't happy, and they've not ordered anything since, because they've churned and gone away. You can actually do this kind of real-time analytics on your data. So we've got our data, and it's customer data. So let's go back to our system. I'm going to go back to my cheat sheet. And to start with, we're going to create ourselves a stream of customer data. So from that stream of customer data, we can have a look at what's there. Okay, so here's my users. There's user ID 42, Mr. Rick Astley. There's 42, Fu Astley. That's a stream of data. Okay, I'm not going to go into stream table duality because I don't want to overrun into the next session. It's a very cool thing. Ask me about it afterwards or go and read it on our website. It's on the full slides as well. But this is a stream, and we're going to change it into a table because customers are a table. So again, what we're doing here is we're using KSQL to actually modify our data, to wrangle it. We're repartitioning our data here to give it a key. So if you're working with Kafka, usually you'll know things have keys, they have replication factors, they have partition numbers. You can use KSQL to actually modify these and create derived topics. I've got a topic with 2 partitions, it needs to have 10. I need to increase the replication factor, KSQL. Original topic gets updated down to target topic. So now we've got a table. And now I'm going to select from that table. So if you remember, this is our stream, where ID equals 42. We have 2 events on our stream. Okay, these were the events that came through from the database. Change events. Something was created, something was changed. But now, let's see what our table tells us. Our table tells us for ID 42, it's Fu Astley. A table gives you the value as of now. Doesn't tell you what it was before, that would be a stream. Tells you now, this is the value. So when we're joining between our inbound ratings, who's this customer, we want to join it to the current value. We don't want to end up with kind of a Cartesian join, because that would be weird. So now, let's do the join. I'm going to copy and paste it so I don't make any typos. But this is the cool stuff. The backslash is just a line continuation character. So select the rating and the message, select the first name and the last name, do some concatenation. So you can do transformation on your data as it flows through. Then we've got the club status from ratings, left join customers, where the first name is not null. So do some data cleansing as well. So from that, so this is just SQL, okay? We can do the select, it's going to come back, it's going to show us this enriched data. Okay, there's a ton of data, and it's all rating, message, customer. So what we can do is we can persist it using create stream as. So exactly the same thing as before. Create stream ratings with customer data. So now I have a Kafka topic being populated by the results of that join in real time. If I make a change in my database, new events coming through will reflect that change. And I can take that data and I'm going to create another derived stream on that. So from that, I'm going to create a stream called unhappy platinum customers. Because you can daisy chain your statements. So you can say, well, first I'll join. Okay, I'm not going to throw any data yet. I'm just going to join it. And then from that, because that could be useful to lots of different applications. Lots of applications could want to know about users leaving ratings. But for another purpose, a specific business purpose, we want to know about important customers who have left bad reviews. So we can do that. Create a stream on happy platinum customers, select their details. Where's my cursor? Select their details from the stream we've just created with our predicate where stars is less than 3 and their platinum. You'll also notice I'm changing some characteristics of the target topic. I'm saying, actually, let's use JSON here. I wouldn't advise it, but you can use JSON if you want to or you need to. And we're going to have a single partition. So now that's up and running. So we've got our ratings data, we've joined it to our customers, we've taken that and we've filtered it out for one's important customers leaving bad reviews. So now, what we should be able to do is 2 things. Let me show you this one. And in the meantime, this is the first time I've ever tried this demo, so it'll probably crash and burn. But this one's proven and tested. So this is this is Elasticsearch. So this is Kafka topic, Kafka Connect, pointing at that topic, streaming events as they happen down to Elasticsearch. So Elasticsearch, document store, lovely to work with, easy to chuck data at. Okay, it's refreshing every 30 seconds. We can make that 5 seconds if we want to. But we've now got a real-time analytical view on our data. So there it is, 1946. I've overrun, apologies. But there's my unhappy platinum customers. We've got a dashboard about what's happening in our operational system in real time. The other thing we've got, let's see if this will work. So this, basically I've set up, do you know, is everyone familiar with Slack? Yeah? So Slack, it's a messaging thing, and you can use it for sending push notifications. There we go. Phew, it worked. So this is my phone now getting push notifications driven by that topic we created. So it's an event-driven application, and all that application has to do is subscribe to a Kafka topic and listen for those messages. And when they come in, it says, oh, I need to do something with that. I'll send it to Slack. So we don't have to write an application which says, I've got this topic here, the ratings, I've got my database over there, I need to do a lookup, here's my logic to apply to it, blah, 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 and I'll send it to Slack. Classic kind of like bundle of crap. We have a single application with a single responsibility for, and there's an event, I'm going to send an alert based on it. Okay, it worked, I can't believe it. I can. I thought it might. So, with that, there we go. So this is all built on Confluent open source. So Confluent's a distribution of Apache Kafka, Confluent open source, free to download, free to use. You've got the schema registry for your Avro schemas. You've got KSQL, you've got Kafka Connect, a bunch of connectors, all bunches of good stuff. There's some free books you can download. Scan the QR code, it'll go to the link. But those are some seriously good books. If you're into your Kafka, you can get those for free off our website. Download Confluent Platform from there. That's my contact details. Obviously, I'll be around afterwards, but please do send me questions if you have them. So with that, I will hand over to the next presenter, and then after that, we'll do some questions. And obviously, I'm around afterwards as well. So thank you.
Hola, buenas tardes. Gracias por venir a este Meetup y gracias a Google Campus por dejarnos este sitio para dar estas charlas. Mi nombre es Antonio Abril, soy arquitecto de software en Stratio y bueno, hoy gracias también a Robin por esta magnífica charla, ha sido súper interesante. Yo os voy a enseñar lo que es un ejemplo de Kafka orientado a redes sociales. es un ejemplillo muy sencillo. Es una aplicación que simplemente lo que hace es levantar un Kafka, conectarse con la API de Twitter y vamos a ver de una forma bastante gráfica y visual cómo entran todos los tweets que sean más retuiteados en ese momento. ¿Qué es lo que vamos a utilizar? Vamos a utilizar, como podéis ver, es una aplicación que lo que hace es en tiempo real nos permite estudiar todos los tweets que van entrando, se conecta con un productor de Kafka y luego los envía mediante Spark a un microservicio que vamos a levantar con Spring Boot. Esta sería un poco la arquitectura que vamos a tener. Simplemente tendríamos nuestra API de Twitter, que es la que va a enviar los datos de transmisión a Kafka. Tenemos nuestro nodo de Kafka, que es el que va a almacenar esos datos dentro del servidor y va a tener todos los suscriptores. Y mediante Spark vamos a procesar en streaming todos esos datos de procesamiento para poder filtrar, agregar y si queremos insertar datos desde otra red social, como puede ser Instagram, Facebook, también podríamos hacerlo con Spark. Para finalmente podríamos persistir en cualquier tipo de base de datos que nosotros queramos. Ya puede ser SQL, no SQL, y bueno, tienes un poco las bases de datos que más se utilizan para este tipo de aplicaciones. Características principales. Twitter. ¿Por qué lo usamos? Simplemente lo usamos porque podemos conseguir información en tiempo real de eventos, conciertos, eventos deportivos, lo que nosotros queramos. ¿Qué más podemos conseguir con esta API? Podemos conseguir historial de personas o empresas que necesitamos conocer. Bueno, aquí últimamente se está viendo que se consiguen datos de, por ejemplo, los políticos se están dejando de evidencia con este tipo de aplicaciones, por ejemplo. También podemos localizar personas o empresas por localización física. O sea, mediante esta API nosotros podemos saber desde dónde está tuiteando cada persona que está emitiendo un tweet. ¿Qué beneficios nos aporta esta plataforma en comparación con otras? Es una de las más usadas y a través de microblogging podemos acceder a datos y noticias en tiempo real y luego conocer qué es lo que opina la gente de esas noticias. ¿Cómo funciona la API de Twitter? Es muy sencillo. En la página de appstwitter.com te registras y te creas una aplicación y simplemente te da una serie de tokens, que esos tokens son los que luego tienes que utilizar tú en tu aplicación para hacer la llamada a la API de Twitter. Mediante Kafka, bueno, ya nos ha contado Robin las maravillas de Kafka, pero bueno, estas serían otras características que tenemos. Un broker de Kafka es muy rápido, es escalable, es duradero, es distribuido. Por ejemplo, rápido, nosotros en Stratio tenemos proyectos en los que prácticamente está ingestando 15.000 eventos por minuto y sin despeinarse. O sea, es un tipo de software muy rápido para cualquier aplicación que queráis usar. Otras características es que los mensajes los sistemas de mensajería tradicional utilizan a lo mejor solamente los dos módulos que son el QR peer-to-peer y luego tenéis el otro que puede ser el del Pro Services. Kafka tiene una ventaja respecto a los sistemas tradicionales y es que puedes utilizar el Consumer Group, que te permite agrupar este tipo de funcionalidades. Estadísticas. Bueno, como podéis ver en comparación con Rabbit y con ActiveMQ, se ve claramente que bueno, Kafka es súper rápido. Características de Spark. ¿Para qué lo usamos? Spark es un sistema de computación en clase rápido. Tiene lo que es el ecosistema de Spark. Tienes librerías MLib, tienes procesamiento de gráficos y también tienes Spark Streaming. ¿Qué es lo bueno de Sparse Streaming? Pues que puedes procesar volúmenes muy grandes de información en un tiempo muy corto. Lo bueno también de Sparse Streaming es que ofrece cálculos de memoria mucho más rápidos que otras plataformas y bueno, la diferencia de otros sistemas es que lo procesa en memoria, no tienes necesidad de guardarlo en disco. Esta sería un poco la arquitectura de esta aplicación. Y bueno, básicamente Kafka, vamos a tener un productor que mediante esta API le vamos a indicar dónde está corriendo, el nodo y dónde vamos a escribir los mensajes. Y luego tendríamos el consumidor, que es el que va a crear los mensajes indicando el host, el puerto donde está arrancado el broker. Configuramos los parámetros como puede ser el timeout, tamaño del buffer y luego el identificador del consumidor. ¿Quién utiliza este tipo de arquitecturas? Pues muchas empresas para editar redes sociales. Si necesitas pedir algún tipo de informe de alguna persona, alguna empresa, hay miles de empresas que se dedican a esto. Se utiliza también para campañas de marketing. Muchas fuerzas del orden lo utilizan para medir eventos, para saber si va a asistir mucha gente, un poco para controlar el volumen de población. Y los gobiernos, por ejemplo, lo están utilizando mucho para conocer la orientación de voto de cara a las elecciones. Bueno, este sería un poco el diagrama de secuencia de la aplicación que vamos a ver. ¿Qué es lo que hace? Básicamente tenemos nuestra API de nuestro servicio de Twitter Producer, que es el que va a conseguir los tweets. El API de streaming de Twitter nos va a devolver los tweets y nosotros los vamos a mandar al topic de Kafka. El topic de Kafka luego lo va a mandar al Sparse Streaming, los va a procesar y los va a mostrar por consola. Vamos a la demo. Bien, como os contaba, esta sería esto sería lo que vamos a mostrar por consola. Aquí podéis ver cómo vamos a recoger todos los tweets que estén en idioma español. Y lo que vamos a mostrar por consola es simplemente el nombre del usuario, el texto del tweet que está publicando, que está retuiteando, y la localización de ese usuario. Para levantar la aplicación es muy sencillo. Con Spring Boot tiene embebido un Tomcat. Entonces, simplemente con levantar esta clase, aquí tenemos el método main. Y aquí vemos cómo empieza a correr, cómo empieza a levantar un Kafka. Bueno, el Tomcat que está levantando, que tiene embebido. Empieza a levantar la JVM. Y aquí ya estamos viendo los tweets que están recibiendo. En este caso, pues por ejemplo, podéis ver el usuario, el tweet que está retuiteando. Y bueno, la localización al final, pues en este caso está entrando de El Salvador. Este usuario no tiene. Lo voy a parar para que sea mejor. os contaba, aquí podemos ver lo que está recibiendo. Está recibiendo el usuario, el texto y al final la ubicación. Esta API de Twitter es muy sencilla de usar, es muy configurable y podéis obtener muchísima información que luego podéis guardar en vuestra base de datos, persistirla y extraer muchísima información para lo que vosotros necesitéis. Lo bueno de utilizar esta API, por ejemplo, con otras APIs como puede ser la de Facebook o como puede ser la de Instagram, es que todo ese volumen de información, si tú luego lo mandas a Kafka, todo ese volumen puedes hacer ahí un metadatado y extraer muchísima más información, por ejemplo, de una empresa, de una persona, de un evento, de lo que tú quieras. Luego, por ejemplo, la API lo bueno que tiene es que te permite aquí, por ejemplo, puedes cambiar el idioma. Por ejemplo, lo tenemos en español, simplemente con ponerlo en inglés. Volvemos a levantar la aplicación. Y aquí podéis ver que ahora todos los Twitter que están entrando son en inglés. Con ese código del idioma podéis jugar para guardar toda la información que vosotros queráis. ¿Perdona? Joder, perdón, es que no la he cogido. Fallos del directo. Perdón, es que veo fatal aquí la pantalla. Con este código que vosotros tenéis aquí podéis jugar. Luego también aquí, por ejemplo, si os vais tenéis diferentes métodos por el cual vosotros aquí podréis obtener muchísima información que queráis. Del perfil, por ejemplo, podéis extraer, pues, no sé, todo lo que tenéis. Todos estos métodos os van a dar información de ese perfil. Lo bueno de la API de Twitter, que es gratuita, y bueno, lo que recibís es un 3% de todos los tweets a nivel mundial, de forma gratuita. Luego, si queréis extraer más información, ya sería una cuestión de pagar. Y bueno, simplemente... perdón que no veo bien. Y bueno, esta sería la aplicación usando Kafka, usando Spark y usando la API de Twitter. Con este sencillo ejemplo podéis ver que podemos extraer un metadatado bastante interesante y con un volumen de datos muy importante para que luego vosotros podáis extraer vuestra información. Vamos a pasar, si queréis, ahora al turno de preguntas. ¿Tenéis preguntas para Robin? ¿Sí? Ujú. Robin, one question for you.
The information that is available in Kafka streams, it's only about the message that are alive inside the event manager.
You understand?
The information that is available on KSQL tables is only available if the message are still alive. If you define a lifetime for the messages of 2 weeks or 3 weeks, the data available is only about 3 weeks of events.
Yeah, that's right.
Okay.
So each Kafka topic you set with a retention period, or retention period or size based on the business requirement of that. So you could have a topic that keeps data for 10 years. Yeah, by
But you can-
default
you can
it's
change it.
7 days or something, but you can change it. So it could be 10 years, it could be 5 minutes. It really
Okay.
does depend. There's also something called compacted topics where you keep the data forever, and that's like a special thing you'd use with tables.
Okay, that's right. Thank you.
¿Más preguntas?
Solo por motivar, hay camisetas y regalos para las preguntas, así que...
No, questions.
Okay, so you can connect different different data sources to KSQL, right? So I was wondering, is there a way to create kind of a namespaces or like somehow separate environments so that you can query to just a specific part of all your data in Kafka?
Yeah, so with Kafka Connect, there's something called single message transform, and that's part of your configuration file, and you can use it to apply. You can either modify your target topic with regex, so apply a prefix or a suffix. You can also use it to add in additional columns to the payload, saying where it came from and so on.
Yeah, but when you open the console of KSQL, you access like all data in Kafka, right? So is there a way to access only part of it? So give access only to part of it? Like several, like say you have 10 topics and 2 databases connected. You want the user to be able to access only one of those databases and 3 of the topics. Is that possible?
So let me just check. So you're asking, can you stream in a whole bunch of information and restrict the user as to which ones they can use?
Yeah.
Or you want to segregate your environment entirely?
I want, namespaces in Kubernetes, for example, that you have access to, you can like separate environments. Say you have different projects, so you can like, I don't know if I'm making sense.
Yeah, no, you are making sense. The answer is yes. So how you do it? So with Kafka, you can have wildcarded access control lists. So if my understanding of it is right and it's new, you could use single message transform to say data has come from this database, and the target topic would be database or qualifier, database, name, table, whatever. And then you could say this group of users can access a topic based on that pattern. You could also set up Kafka clusters for specific purposes. So when I mentioned earlier that Kafka admins get nervous when I talk about SQL people hitting Kafka data, you can have your primary Kafka clusters, your operational clusters, and use something like Confluent Replicator or Mirror Maker to replicate particular topics out to a sandbox environment or a analytics environment or a non-sensitive data out to somewhere where anyone can use it, that kind of pattern.
Okay, so this question might be stupid or it might not, but
there's no such thing as a stupid question.
So it makes sense to have different Kafka clusters for different usages, or is it a good idea to have like a huge Kafka cluster that you could use for everything?
That's a really good question and not at all stupid. So all of the diagrams that people do, and I do this as well, it's like stuff, Kafka, stuff. But in practice, you can have, and people do have, multiple Kafka clusters for things such as workload isolation or security. But the crucial thing is, the power of Kafka comes from sharing data between systems and not having these little silos, which is what databases give us. So with Kafka, multiple clusters as a physical implementation, but using, like I say, Confluent Replicator, for example, to synchronize specific topics between them. Because then you have your localized ones with data which would only ever be particular to that use case, but your customer information, your whatever data, which is relevant throughout the business, all of that information, your orders and so on, that replicates across all the different clusters. So you have one logical cluster, but in practice implemented multiple.
Okay, thank you very much, Robin.
That was a great question. You can have two t-shirts.
Ahí arriba.
Hi, Robin. My question is about the SQL and the form that we create indexes. Is there any way to create index, and how KSQL work with left join, for example?
Another good question. So KSQL doesn't have indexes. Kafka gives you the ability to repartition your data, and you can repartition it using KSQL. So it's basically stripping the database back to its bare bones. So you have the concept of a changelog, you have the concept of a key value pair message. But if you know what your data access patterns are going to be, instead of saying create index foo, you would need to go and create a separate topic, which in effect is that index. So it strips it back several layers from what relational databases give us nowadays. But data in a Kafka topic is in sequential order per partition in strict ordering, and it's going to be as the data flows in within each partition based on that key. So if you know that you're going to need to join it on a different key or access it in a different way, you would build that kind of index yourself.
Hi, I would like to know if the SQL that we have in KSQL is completely, it's not a subset, or for example, can I run some queries like a max function, and that is, if I can, does it apply to the amount of data that is at that moment on the stream, or how does it work?
Yeah, so KSQL supports functions, both scalar and aggregate. So that's something that I didn't quite get into in my talk, but you can have aggregate functions, and it can be over everything. But much more usefully is it can be time-based windows. So you could say, looking at my data, give me an aggregate based on every minute, or 5 minutes, or 10 days, or whatever your use case is, and it updates continually. So as new data arrives, the aggregate is updated, but also as late data arrives, the aggregates are updated. So KSQL and Kafka Streams just handle late data like that. So late data comes in, it updates the aggregate, it re-emits the aggregate value. So yes, it does handle aggregates.
The last one.
My question is regarding security. I wonder if you can cipher some channels and then with KSQL maybe join them to make them available to whatever topic you choose. Maybe some topic can be, I don't know, encrypted or something like that. How does security work with this?
So, there's two answers. Security is not my forte, so that's why I hesitate. I don't want to tell you something wrong. Kafka supports encryption, end-to-end encryption. So you can set that up, and whether it's KSQL or whether it's just a standard client or whatever, it can be set up to be encrypted using Kerberos and SSL and that kind of stuff. I'm going to wave my hands a little bit. KSQL also supports user-defined functions. So if you've got something that you've got a particular encryption pattern that you want to write yourself, you could do so, and then you could write it as a scalar or an aggregate function in KSQL. So then instead of doing a min on a column or a trim or a whatever, you could do your cool function to encrypt or decrypt the data. Does that answer your question? One resource which I didn't share and I put on the Meetup group, there's a Confluent community Slack group. It may have been on one of the slides, but it's worth reiterating. There's different channels for every different thing, including security. So there's like 6,000 people on there. There's a ton of Confluent engineers. So if you have questions about security, about ops, about KSQL, all of the different things to do with Kafka and Confluent Platform, the Slack group is a great place to discuss it with the community and with Confluent folk as well.
Well, I'm a totally new to Kafka, so I will try to not say something really, really stupid. I hear before that data has like a time, like a lifetime into Kafka. How can we prevent to lose data before it get consumed by the consumers?
Yeah, good question. So an important thing about Kafka is that even once data is being consumed, it's still there. Data sits in Kafka from as long as it gets sent to the system until it gets flushed out. And it will get flushed out either based on how long it's been there or the size. And you configure that. So you could say, I want to keep data for 3 weeks. Or I want to keep data until I've got 10 gigabytes. And once that limit is reached, it will start to age out the old data, or the data that was at the bottom of the pile, as it were. So it's not about has it been consumed yet or not. It's about what was the retention that you set on the topic. So if you want to make sure that your consumer has got access to the data it needs to, you need to make sure that you set the retention on the topic appropriately. Does that answer your question? More or less. No. Well, you can, I don't know if there are other Kafka experts, please pipe up. I mean, so far as I'm aware, you can look at like consumer offsets and things like that, and you could look at your application, where's it got to, what's the latest offset within the topic, and so on, but that's fundamentally not how Kafka works. And I would also wonder why your consuming application hadn't consumed the data. So perhaps if we have a chat about it afterwards, I can understand more about what you're building. But fundamentally, Kafka is built on this idea of data is retained, regardless of whether you've consumed it.
I'm going to have the chance to have a question. I know it's a little bit hard to respond right away, but what do you think? Well, in fact, I know your answer, but what do you think about another SQL engines like Spark SQL? Because of there are plenty of organizations are already working. What do you think is the highlights to combine or change this technology?
Let me just repeat your question to make sure I understand. Are you basically saying how does KSQL compare to other SQL languages in the big data space?
In big data space, no, in stream space.
In the streaming space, okay.
Space.
So like Flink SQL, Spark Streaming SQL, and so on. So in a sense, everyone's trying to do the same thing, which is everyone recognizes that SQL is actually super powerful. And the whole NoSQL movement was like, oh, we don't need SQL. It's like, oh, it turns out we do. So SQL is very powerful for expressing certain patterns that we want to do to our data. So Flink are doing it, Apache Flink are doing it, Confluent are doing it for Kafka. There's Spark SQL. Part of it's going to depend, and the same thing with like Kafka streams versus Spark streaming and whatever streaming and Beam and so on. Part of it's going to depend on what you're using already. If you're already heavily invested in Spark, would you go and start using KSQL? I'd say yeah, but I'm biased. But part of it's also going to come down to things like the runtime environment. Do you need to go and build a separate cluster? Do you need HDFS and Hadoop and so on to back it up, or as in to underpin it, or can you just use it on a standalone worker? How easy is it to deploy? How easy is it to maintain? Do you have the skills around it? So it's not a kind of a clear cut, this is better, that one sucks. There'll be different, people have their own benchmarks, their own FUD to throw around. I'm going to try and stay clear of that because they're all fundamentally doing the same thing at varying different kind of, one does one thing better, another does another thing better, and so on. I realize that's a bit of a cop-out answer, but it's only fair.
I was just wondering how does a production application with KSQL look like? Because what do you have? How do you deploy it? do you have like a super big SQL file, then you just take it and put it on the console and run it on production to get the results? Or how does the production application look like with KSQL?
So a production application with KSQL, you deploy your KSQL server or servers in a cluster, and that could be bare metal, it could be on Docker, and you pass it your SQL script as an argument to the startup. And so long as your KSQL servers are part of the same cluster, they will take care of like what runs what. But the key thing is they're headless, and you cannot interact with them. So you can't run an interactive command prompt against them. You can't run the REST API against them. It's locked down production. So here is my code. I deploy my code like that. I can't just go and meddle with it over there. Yes, you have a repository of your SQL statements. So you build up your SQL in your development environment. You maybe move that on because it's just code. So the same way as you test and move your other code, the same thing, you put it in your source control, you deploy it in your next environment, and so on. It's just a SQL file, a bunch of different statements. So if the transformations are big enough, the SQL could be horrible to maintain. Yes, but Java code is not pretty either. I mean, code is code, right? And we can be elegant, but if you're trying to express a transformation, it's just code, all right? It's just SQL that you're right to.
You prefer to use Kafka streams?
Okay, so the question, as I understand it, is for complex transformations, would you rather use Kafka streams? I wouldn't, because I can't code Java. You might, because you can. But the whole, do I use KSQL or do I use Kafka streams, comes down to personal preference or ability, but also, can you do what you want to and it perform appropriately in a higher level abstraction, which is arguably easier to maintain, or not if you're a Java native and not a SQL native, or are you trying to do something which cannot be expressed in SQL or elegantly expressed in SQL? You tie yourself up in knots trying to write SQL and 10 different derivations that you could do in one Java statement. Use Java, use Kafka streams. But there's different ways of doing it depending on what functionality you need and depending on language familiarity. And yeah, good point. So UDF functions as well. So you could actually wrap a bunch of stuff in Java, stick it in a function, call it from SQL. Great point.
So, thank you very much for coming. No vamos a hacer sufrir más porque sé que las pizzas huelen muy bien y no estamos haciendo una clase de experimento para ver cuánto soportáis aquí con el hambre que habrá y con las cervezas y demás. Así que vamos a subir para arriba y ahora habrá un pequeño espacio para hacer networking, para que podáis seguir preguntando y hablando con nuestros compañeros. Así que lo primero que os pido antes de subir corriendo, un grandísimo aplauso.
Muchas gracias por venir y bueno, vamos a seguir hablando aquí arriba.
Just before you all go, I have one last request. I do this thing called speaker selfies, so if you would oblige me and just wave at the camera. Go on, you want speaker as no, speaker as well. There we go. Thank you very much.
Thank you.